Okay, so we're going to talk about critical path analysis now for the D2 exam. And to start with, let's discuss why we'd use critical path analysis. So it was basically developed to help organise big, vast projects such as building spacecraft, missiles, and building submarines and things like that. So where you've got lots and lots and lots of different jobs that need doing, and you want to sort of plan the best order to do things in. So for example, a spacecraft, you would want to build all the devices and gizmos inside the spacecraft before you put the casing on. And there's thousands and thousands of jobs that would need doing, and you're trying to find the path through the jobs that optimizes it so it gets done as quickly as possible and most efficiently. So what we're going to do is we are going to first of all come up with some activities that need doing, and have a look at how long they take to do, and what order they need to be done in, and see if we can optimize that and find a critical path through the network of all the jobs that need doing. Then we're going to look at two types of diagrams, Gantt diagrams and resource histograms, that are going to be ways of displaying the same information really, or how we can look at how the jobs need to be arranged. Okay, so first of all, let's start with an example, and I'll go through this. I'm going to fill in this table, and the first row, I'm going to put the jobs that need doing, the activities, and I'm just going to call these job A, activity A, activity B, activity C, D, E, and F. Okay, so those are the jobs that need doing. And the next row, I'm going to put predecessor, and this is what jobs need to be done before I do job A, B, C, D, E, and F. So I don't need to do anything before I do job A. I can do that straight away. Before I start job B, I need to have completed A, and before I start activity C, I need to have completed A. Before I start activity before I start activity D, we'll have to have done B and C. Before I start activity E, I need B and C done as well. And before I start activity F, I need to get D and E finished. Okay, so that's what the predecessors are, what jobs need to be done before I can start that next job. And then the last row is going to be how long it takes to do each activity. So I'm going to say that activity A takes 8 days, activity B takes 5 days, activity C takes 3 days, D takes 5 days, E takes 9 days, and F takes 8 days. So I've got all the information I need there about all the activities, the order they need to be done in, and also how long they take to be done. Okay, so what we're going to do now is this activity network that's going to help us do the algorithm to find the critical path. So I've got this sort of rectangle thing here. I'm going to put activity A in there, and in the middle box I'm going to put how long it takes to do the activity, 8 days. Okay, and I'm going to grab box here, and I'm going to put activity B in here, and B takes 5 days to do, and it needs A to be done, so I can go from A to B, so I'm going to put a little arrow like that. Same for C. C takes 3 days to be done, and I need A to be done first, so I'll put an arrow coming from A. And then I've got activity D. Takes 5 days to be done, and I need B to be done and C to be done. So there's 2 arrows coming towards D. I've now got activity E here, that takes 9 days, and requires B to be done and C to be done. And then finally, I've got activity F, and it needs D to be done and E to be done. And it takes 8 days itself. Okay, so that's my activity network. And now what I'm going to do is I'm going to add in to these boxes the earliest start times, the earliest times that each job can be started. And that is going to go in this box on the left. So this box on the left is the earliest start time. Okay, and we're going to have a look at how we work that out. So for job A, there's nothing holding job A up, there's nothing it relies upon, so it can start on day 0 and just get started straight away. Now if it starts at time 0 and it takes 8 days, that means job B can be started on day 8 and job C can be started on day 8. It can't be started any earlier because job A takes 8 days to be done, and B and C rely on A being done before they can be started. Okay, so now let's have a look at when we can start job D. Okay, what's the earliest start date for job D? Well, if I look at B starts on day 8 and takes 5 days, so it could be finished by day 13. But C starts on day 8 and only takes 3 days, so it could be finished at 11, on day 11. So C will be finished by day 11 and B will be finished by day 13, but D relies on C and B both being finished. So I'm going to pick the highest of the two numbers. So I add the two numbers up. 8 add 5 is 13, 8 add 3 is 11, and I pick the largest because that's the earliest it could start because it relies on both of them being done, so I pick the biggest. And it's going to be the same for A as well because they both rely on B and C being done. Okay, so what's the earliest F can start? Well, D can start on day 11, takes 5 days, so it could be done by day 16. And E can start on day 11 and takes 9 days, so it could be done by... I think it's wrong, haven't I? Okay, right. So let's have a look at the earliest day that D could start. Well, D is reliant upon B and C being finished. So activity B could start on day 8 and takes 5 days, so it could be done by day 13. Activity C could start on day 8, takes 3 days, so it could be done by day 11. But activity D requires C and B both being done, so I'm going to pick the biggest number. So 8 add 5 was 13, 8 add 3 was 11, so I'm going to pick the biggest number. D can start on day 13. It requires both of them being done. So what I generally do is I add up the two numbers, 8 add 5 is 13, add up the two numbers, 8 add 3 is 11, and I pick the biggest because D is reliant on both of them being done. If I couldn't start on day 11, I'd have to wait till day 13. And it's going to be the same for E. That's going to be 13 there because it's reliant on B and C as well. Okay, so let's have a look at the earliest time that F could start. Well, F is reliant on D, and D could be finished by day 18, 13 add 5. But it's also reliant on E, and E could be finished by day 22, 13 add 9. So I'm going to pick the biggest because I need both of the jobs to be done. Okay, so what I've got there is the earliest start dates for all the activities. Okay, I'm now going to fill in the other box, which is the latest end day. Okay, this is the latest we could end by. So if I started F on day 22 and it took 8 days, then it's going to be finished by 30. So we're aiming to get the whole project finished by day 30. So I'm going to go back from right to left now, and I'm going to put in the latest dates that the activities could be finished by. So I do 30 take away 8, so I'm looking at the last two boxes, and I do 30 take away 8, that gives me 22. So D needs to be finished by day 22, and E needs to be finished by day 22, so that F can be started. So let's have a look when B needs to be finished by. Okay. Well, let's look at D. D needs to be finished by 22, so it can take away 5 days. That's the time it takes to be done. So D could be finished. We could start D on day 17, and it would still get finished by day 22. So 22 take away 5 is 17. So that's okay for D. And then 22 take away 9 for E means that E could get started on 13 and still be done. Okay. Now I'm going to pick the smallest number. Not like when I went from left to right, I added up the two numbers and picked the biggest. Here we're looking for the latest start, the latest end day. So here we're looking at the latest end day. So 22 take away 5 is 17, and 22 take away 9 is 13, and I'm going to pick the smallest. So the latest date I can finish B by is 13, which means that E can get started on day 13. Okay. And also, the latest that C can get finished is 13. Okay. I'm going to do the same again for A. What's the latest that A could get finished? Well, 13 take away 5 is 8, and 13 take away 3 is 10, so I'll pick the smallest, I'll put 8 in there. Okay, so now I've got the earliest start date for each activity and the latest end day for each activity. So let's have a look through some of these activities now before we move on. And let's have a look at A. You'll notice in A, if I take the first number, 0, and the second number in the box, 8, and I add them together, I get the third number in the box. Okay, and this means that if the earliest I start A is at 0, and the latest I can finish A is day 8, and it takes 8 days, there's no leeway in that. There's no spare time, so that activity is critical. Okay, and the same for B. If I look at B and I do 8 add 5, I get 13. So we'll start B on day 8 and it takes 5 days. It will be finished by 13 and there's no spare time, so that activity is critical. If I look at activity C, I can start it on day 8. It takes 3 days, which means it'd be finished by day 11, and I've still got 2 days left over. So activity C has 2 days leeway, and we call this 2 days float. We call it the float time. So the float on activity C is 2 days. Okay, so it's the difference between 8 plus 3 and 13. Okay, so let's have a look at D. D, we've got some float time on as well. 13 over 5 is 18, so the float on D is 4 days. There's 4 days spare, 4 days leeway on D. 13 and 9 is 22, so E is critical. And F is critical as well. 22 add 8 is 30, so this one's critical. Okay, so the critical path the activities that need to be done are A, B, E and F, and the other activities there's a little bit of leeway or float time involved with them. Okay, so that's the critical path and that's how we find it. Okay, so now what we're going to do is we're going to look at something called a Gantt diagram, which is a way of displaying the same information that we've just found. So I'll come down a little bit, and this is going to be called a Gantt diagram. And all we do is we take the information we've just gained from the activity network and we're going to plot it in this chart here. So for example, activity A starts on day 0 and takes 8 days. So I'm just going to thing here. Activity A starts on day 0, takes 8 days, so I can do that on my Gantt diagram like that. It's a long rectangle that represents activity A, and it takes 8 days. Okay. Activity B can start on day 8 and it takes 5 days. Okay. So activity B starts on day 8 and takes 5 days, so it finishes about there, and then and that's activity B. Activity C, well, there was some float time with this, and what I'm going to assume is, I assume that I start the activity on day 8 and it takes 3 days, but I've got 2 days float before day 13, so I'm going to start it on day 8, start it as soon as I can, but it only takes 3 days, so it's going to be from day 8 to day 11, like that. Just move that out of the way. Try that again. So it takes, we assume it starts on day 8 and takes 3 days, but there is going to be some float time, 2 days float time. So I'm going to put that in as a little line like that with a bar on the end to say there is a little bit of time where I can run over with that job. Okay, let's have a look at activity D. D starts on day 13 and takes 5 days, but there's 4 days of float. Okay, so let's do that. So it starts on day 13 and it takes, what did we say, 5 days, so 13 to 18, like that. So we assume it starts straight away, but then there's 4 days of float, so that takes me to day 22. And then activity E. Activity E starts on day 13 and takes 9 days, and there's no float for activity E. It starts right there, a little bit there, and it takes the whole 9 days, all the way up to day 22. So that's activity E. And then finally activity F takes the whole 8 days up to day 30. So it starts on day 22 and takes the whole time up to day 30. So about there. Okay, so I've got activity A, activity B, activity C with a little bit of float, so there's some leeway in when we can start that. Activity D has some float as well. Activity E, no float, it's critical, and activity F there, it's critical. So we can get finished by day 30, and there's a little bit of leeway in C and D. And that Gantt diagram is just another way of representing what we just found out with the activity network. You guys all right? Okay, finally, we're going to do another chart that is going to help us visualize what resources we need to get these jobs done. And this is going to be called a resource histogram. Okay, and on this chart, I've got the number of workers I employ on the left and the number of days it takes on the right. And I'm going to assume from all the stuff I've done so far that, for example, activity A takes 8 days if one person is working on the job. Okay, so if I look at this Gantt diagram now, for the first 8 days, I just need one person to be working. Okay, so the first 8 days, I just need one person employed. Okay, that's the first 8 days there. It takes one person 8 days to do it. Okay. Like that, you see. So from day 8, we're going to need 2 people working for 3 days. So that's 8 to 11. So we're going to need 2 employees now for 3 days. And then after the 3 days, we're just going to have one person working on B for 2 days, because there's 2 days float on C. So I've got another 2 days here. So I just need one employee again. Okay. So let's put that in. So I needed to employ an extra person for just those 3 days then to get job C done. Okay. And then from day 13 to day 22, I'm going to need 2 employees. Well, I need 2 employees up to day 18, and then I can drop down to 1 employee because I need 2 employees to do job D and E, but D only is going to take up to day 18. So we're going to need 2 employees from now to day 18. So let's go back up to 2 employees, and we go across to 18. That, and then finally from 18 I'm going to be doing job E up until day 22, and then I can start job F from 22 to 30. That's still only going to take one person because I'm going to go from one job to another job, so I need just one person employed from 18 to day 30. Okay, so that there is my resource histogram. Okay, and it's basically just showing me how many people I need to employ at for different days. Okay, and that's it. So that's another way of sort of planning how I'm going to get this activity done. So first of all, I've done the activity network. I found the earliest start dates by going from left to right, and I add up the first 2 numbers and pick the biggest. And then when I've got all those, I go from right to left, and I do the number on the right, take away the number on the left, and I pick the smallest, and that gives me the earliest starts and the latest finishes. I can then take all that information, put it in this Gantt diagram, and put in the floats as well. I assume that every job starts as soon as it can. And then finally we've got this resource histogram here that tells me how many people I'm going to need at different points through the job.